everyone, welcome back. In this particular video, we will be discussing the problem. Find if string permutation can form a palindrome. We are given a string S, which will consist of both lowercase and uppercase alphabetical letters. It means there will be a string, there will be a collection of characters, and the characters will be either small a till small z or capital A till capital Z, lowercase and uppercase alphabets only. You have to write a function to check if the string is a palindrome permutation or not, if it is a permutation of a palindrome or not, palindromic permutation. Now, some points are given, some notes are given. The note says characters are case sensitive. It means small a is not same as capital A. You have to treat them differently. But the point is, what is a palindromic permutation? What is a string which is a permutation of a palindrome? If I take the example of NNAAMM, can I form a permutation of this string? That is, can I rearrange the characters of this string to make a palindromic string? And the answer is yes, true. Why? If I will make this string become N, A, then let's say M, then again M, then A, N. So this string NAMMAN, this is a palindrome and this is a permutation of the original string. Why? There are two N's, there are two N's, there are two A's, there are two A's, there are two M's, there are two M's. So each and every character is present same number of times. So it is a palindrome. Answer is true. What about hello? There is no possible way to rearrange the characters of hello to make it a palindrome. Like hello itself is not a palindrome. What are the strings which are palindromic strings? Which read same from left to right and right to left. Namam, this NAMMAN, it reads same as both the ends, same in both the directions. But if I take any palindrome or any permutation, you can say, not palindrome, but any permutation of hello, it will not form a palindrome. Hello itself is not a palindrome. If I take maybe E, L, L, O, H, any other permutation, like if you rearrange it in any other form, it will never be going to become a palindrome. So answer will be false. Same for capital A, small a, B. Why? This string itself, capital A, small a, B, is not a palindrome. If I take B in the middle, capital A, small b, small a, you would say it is ABA in both the ends. But as given in the question, it is mentioned that characters are case sensitive. Small a should not be treated same as capital A. So capital A should be treated differently than small a. So these are different. So again, it is not a palindrome. So there is no permutation of AAB where one is capital A, another is small, to make it a palindrome. So answer is false again. I hope the question is clear that we have to check whether a palindromic permutation of the input string exists or not. So we will be given a lot of strings, but we have to write the function or write the code for one string. That is to check one particular string whether it is true or false. Now the point is how we can actually find out. See, if I am giving you a string A, B, what you can do actually in order to check whether it is a palindromic permutation, you can search for all the characters. That is, you can maybe try to first do the permutation of AAB as AAB itself. That is AAB itself, whether it is a palindrome or not. Check whether it is palindrome by running a loop from left to right and right to left, by running two pointers and comparing. Is A equal to B? No. So it is not a palindrome. Maybe take another permutation. Let's take BAA. Now check whether this permutation is a palindrome or not. So B is not same as A. Hence BAA is not a palindrome. But as soon as I take ABA, then it is read same as left to right, right to left. So yes, it is a palindrome. Hence this input string AAB was a palindromic permutation. So answer will be true. So one such brute force solution which we have discussed right now is find out all the permutations of a given string using any inbuilt function. You can find out all the permutations in how much time? In n factorial time. Why? For a string having 3 characters, if all the 3 characters are different, the number of permutations of this string will be 3 factorial. That is 6 permutations will be there. ABC, ACB, BAC, BCA, CAB, CBA. These will be the 6 permutations. So in worst case, you have to check for all the permutations. So it will be n factorial permutations. And to check whether a given permutation is a palindrome or not, you have to run a 2-pointer technique for linear time. Overall time complexity will be n factorial into n. You can say it will be almost exponential, very large time complexity. But the point is, can we do better? Can we just solve it in maybe polynomial time, not exponential time? That is maybe n square, something like that. And the answer is yes. See, if we are given the string n, the same string which was given in the input, this was a palindromic permutation. Why? We were able to take one n in the first, another n in the last, one a in the first, one a in the last, after n, one m in the first, another m in the last. That is n, m. So can't we just check whether the number of characters are existing in pairs or not? Because if any character exists in pair, it can be placed one in the left hand side, another in the right hand side, one in the left hand side, another in the right hand side, one in the left hand side, another in the right hand side. And if you will keep on doing it, what will happen? You will make sure that you are forming a palindrome, because if one is in the left, another is in the right, same character, though overall answer which you will create will become same when read from left to right and read from right to left also. So what we have to do is we have to check whether all the characters whichever we have are existing in pairs or not. If they exist in pairs, then yes, the answer is true. The string is palindrome. But will it be the only scenario when there will be a palindrome? Are there no corner cases? Are there only even length palindromes? In this case, we can say all characters were existing in pairs. So yes, the answer is true. What about if one of the characters is 4 times? Let's say capital A is 2 times and small a is 4 times. In this case also, you can say we can form a palindrome by 2a in the left, 2a in the right, and capital A in the middle. So it is not only pairs. You can now say that instead of checking for pairs, we can check for even count, whether each and every character present in the input string is having even frequency or not. Small a having 4 frequency, capital A having 2 frequency, even frequency. So if it is even frequency, it can be completely divided. Half of the characters will go in the left hand side, other half of the characters will go in the right hand side. So now a better thinking or a better solution will be check whether every character is even a number of times occurring or not just in pairs, but even number of times. But again, will there be no corner case? The point is, still we are taking an even length string only. How about an odd length string? Can a odd length string never become palindrome? Answer is no, they can become actually. That is, if I take a string madam is a palindrome and it is of odd length, 5 length. But in this case, you can say M is existing in pair or even length. A is also existing in pair or even length, but D is alone, D is a single. So in odd length string, the middle character can be unique. It cannot exist in pair, like it can be in odd length. So if I take an example of A is present 4 times, capital A is present 3 times, small b is present, let's say 4 times or maybe 6 times. What about this string? Will this string become a palindrome? Answer is yes. Why? Out of 4 A's, 2A in the starting, 2A in the last. Okay, done. Out of 6 B's, we can say 3 B's in the starting, 3 B's in the last. And the character which is capital A, it is odd number of times. So we can place all the characters in middle, odd number of characters in the middle. Why? Because if there will be all characters in middle, the middlemost character, it will not require a duplicate. It will not require same element. Why? Because all these are same as this. Left to right, right to left is same, and middle is also same. So we can say overall string is a palindrome. So one character can have odd frequency. What about 2 characters having odd frequency? If I will take a string as A, then capital B, capital B, capital B, is this string ever going to form a palindrome? Is permutation ever going to be palindrome? Answer is no. Why? Out of 2 A's, let's say I am saying 1 A in the left, 1 A in the right. Out of 2 B's, out of 3, we are taking 2. We are saying 1 in the left, 1 in the right. Now, you have 1 A left as well as 1 B left. So you have to take them in the middle, obviously. But as soon as you take it, is this string a palindrome? No. From left to right, it is AB, AB, BA. From right to left, it is AB, BA, BA. So it is not same. So if there are two characters with odd frequency, two characters with odd number of occurrences, we can say answer is false. Two or more than two. Even if there are three characters, obviously, then also it will be false. So either the number of characters with odd frequency, it should be either zero, that is all characters are in pairs, even length palindrome, or the odd number of characters, the characters with odd frequency, it should be only one such character which is having odd frequency. There should not be more than one characters with odd frequency. So we can check this in order to optimize the solution, in order to write the solution in polynomial time. And how much polynomial? First of all, we have to figure out the frequency of each character. Given the string, we can use a data structure to store the frequency of each element. In order to store the frequency, we need the character, comma, we need the frequency of that character. That is for n, n, a, m. We have to store n, comma 2, a, comma 2, m, comma 2. So these are key value pairs. And the data structure which can be used to store key value pairs is hash map, or you can simply map. That is, we have to implement hashing algorithm. We can use any inbuilt functions to do it, but we have to use a key value pair data structure in order to store the character as the key, comma the value as the frequency of that character, of that key. And once we know the character's frequency for each character, we can check how many odd characters are there, how many characters with odd frequency are there. If number of characters with odd frequency are either 0 or 1, good enough. String is a palindrome, return true. Otherwise, if number of characters with odd frequency are more than 1, that is at least 2 if they are, then answer is false. So this is the logic. And to maintain the data structure, since we are going to maintain a key value pair data structure, we are going to run a loop on the input string to find out the frequency of each character. It will take order of n time. Second thing, now to check whether which characters have odd frequency, we have to run a loop on the key value pair. We have to check for each character what is the frequency of it. So how many different characters can be there? 26 lowercase, 26 uppercase in the hash map or in the hashing algorithm data set, the key value pair data structure. There can be at max 52 different types of characters. Only unique characters will be there. So the second loop will require order of 52 time, which is almost constant. So overall time complexity will be linear only. What about space complexity? As told, the hash map will be required, but hash map will be at max of 52 size only, because different number of characters are only 52. So the hash map will take constant space in terms of strings, because even though the string might be of this much length, 1 lakh or 10 to the power 5 length, whatever, but the number of unique characters among those 10 lakh characters or those 10 to the power 5, 6, whatever characters are there, the number of unique characters will be only 52. So space complexity will be constant, time complexity will be linear. Let's just do what? Let's directly jump on to the instruction manual, that is milestone 3. Now the approach is done. So what we are going to say is create a hash map, create a hash map of character as key and integer as frequency, because the frequency will be the value. We can say integer will be the value because frequency is nothing but integer. So let's say the hash map name is frequency. And what we need to do is run a loop on every character on the input string. Run a loop over all characters of input string S and just insert them in the hash map. So do the frequency plus plus for the character in hash map. Do the value plus plus for the current character as key, for the current character key in the hash map. Obviously, that is whatever character we will have, we will do the frequency plus plus. Let's say initially the hash map is empty. We will say n frequency plus plus, 0 plus 1 will become 1. Again n is there, 1 plus 1 will become 2. A is there, 0 plus 1 will become 1. Again A is there, 1 plus 1 will become 2. M is there, put the new frequency, which is 0 plus 1, 1. And now again M, so 1 plus 1, 2. So whichever character is there, just do the frequency plus plus and take the old frequency as 0 if it is not there. Default value should be taken as 0. So do the value plus plus for the current character in frequency hash map. Once we know every character's frequency, now we need to maintain a variable odd. which will count the number of characters with odd frequency. So set odd variable, odd integer variable, let's say, with value 0. Initially, 0 characters are there with odd frequency with value 0. And now run a loop over all the characters in hash map, over all characters in hash map. Check if the frequency of that character is odd or not. Check if value of that character of that key is odd or not. If it is odd, then what we have to do? We have to just simply do the odd plus plus. Odd will increment by 1. And finally, we need to check whether the number of characters with odd frequency are 0, 1, or more than 1. So if the characters with odd frequency is 0 or 1, then we can say yes, answer is true. So then return true. We can have a palindromic permutation. Otherwise, we can't have. So else we have to return false. So this will be the pseudocode. Now we will be writing the code in Java programming language. So first of all, what was required is we have to create a hash map. That is a key value pair data structure. Hash map with key as character, value as integer. That is, character will have how much frequency that we need to store. Let's say the hash map name is hash map itself, and we will say, as soon as we write this line, we are creating an empty hash map with 0 key value pairs initially. Now to fill it, we have to run a loop on the input string. So I will run a loop on all the characters of input string, that is from index 0 till index less than string dot length. And whatever character we have, we will do the frequency of that character plus plus. So for that, we have to get the old frequency first. So let's say old frequency will be the frequency hash map dot get is the function name, and put the character, that is s dot char at index, the current character. But if the old frequency is not there, if the character is not present in the hash map, what should we take? Initially, we should take the frequency as 0. So we have to take the default value as 0, but get function will not return 0 if the character is not present, if the key is not present. It will give you null. We don't need null, we actually need 0. So we can use a function get or default, and we can pass a second parameter as 0, which will give me value 0 when the key, the current character, is not present in the hash map. That is, when it is being added for the first time, old frequency will be 0 and new frequency will become 0 plus 1. So now what we have to do? Put the frequency of the same character, but this time as old frequency plus 1. That is, frequency will become plus plus. The value will become plus plus. So this is how we have to do frequency plus plus in Java language for a hash map. Once we are having the frequency of each character, let's just for now print the frequency hash map to confirm whether all the characters are getting correct frequency or not. So let's just return true in the last for now and see if the output of the hash map is correct or not. All the key value pairs are getting constructed easily or not. So there is some problem with the return type. The return type is integer in Java. That is, for the answer as true, what we have to do, as you can see, if a flag is 1, return true, or print true actually. So we have to not return true, we have to return 1 instead of true. Similarly for false, instead of returning false, return 0. So if I will run it again, hopefully the hash map should be printed for now. So it is A2, M2, N2 for the string NNAAMM. And for the string hello, it is E1, H1, L2, O1. In some order, hash map does not have ordering. So the hash map is getting constructed correctly. But now the point is how we can actually check the number of characters with odd frequency. So for that, we are maintaining an odd variable, initially 0. That is, till now there are no characters with odd frequency. And now we will run a loop over the hash map. How you can run a loop over the keys of hash map? One by one, we will get a key using the hash map frequency dot key set function. Key set will actually give you the set of all the keys, and you are running a loop on all those keys and one by one getting the character. And to get the value, get the frequency of that character, you can just use the get function. So you can just say the value is nothing but frequency dot get key. And now we have to check whether this value is odd or not. If this value modulus 2 is 1, this is the condition to check whether a value is odd or not. We have to do frequency, or not frequency, but the odd number of frequency plus plus, odd variable plus plus. And why we are doing it? We need to check whether the input string have how many characters with odd frequency, with the unique element which can be taken in the middle. At most one middle can be there. That's why we need to check either the number of characters with odd frequency should be 0 or the number of odd frequencies should be 1. You can simply write it like odd should be less than equal to 1 also. In this case, we have to return 1, otherwise we have to return 0. So else we can say return 0. Let's just run this code and see if it is now working for all the test cases. Hopefully it should. Let's see. It is taking some time to run. Let's wait for the output. So sample test case is working. The first test case is a palindromic permutation. So true answer is there. And hello is not a palindromic permutation. So false answer is there. Let's just submit it to confirm for all the test cases. Again, taking some time to run, but hopefully it will be correct for all the test cases and it will get accepted. So as you can see, all the 28 test cases are getting accepted, and the time complexity, as we have discussed in the approach video, we can discuss it again. We are creating a loop. We are running a loop over all the characters of input string. If input string have n characters, this loop will be running for n time. The get function or the put function or the get or default function, all these functions in hash map take constant time in average case. So overall, this loop will be constant functions. So overall loop will take linear time only, that is order of n time only. What about the second loop? Since the frequency.keyset function will only return unique keys and number of unique keys can be 52 at max, the second loop will run for 52 times in worst case. That is constant time. So linear plus constant is linear only. So overall time complexity is linear, order of n. What about space? As told, hash map will only contain unique keys, that is 52 keys in worst case. The space complexity is a constant. Even though there is an auxiliary data structure hash map, still space is constant due to the number of keys present in that. It is independent of the string length, because string can have a lot of characters with same value, but the hash map will only have unique characters. So that is a problem. Find if the string permutation can form a palindrome or not. With that, we are done with all the 5 milestones. We will meet in a new video with a new problem. Till then, bye-bye. Take care.